Hey everyone, today we're going to be talking about moments in 3D, and we're also going to be using cross products to find moments in 3D problems. Okay, so what we have here are two separate examples. In this method over here, we're going to use cross products, and this one we're just going to talk more conceptually about moments in 3D and not use cross products. So let's start with this one over here. First of all, the one slight difference between moments in 3D and moments in 2D is you have to now keep track of which moment the force, or which axis the force is creating a moment about. Because the force may be creating a moment about the x-axis, but it's not creating any moment about the y or the z-axis. So something to just be careful of and keep track of. Also, it becomes a little more difficult to see if our moments are negative or positive in 3D until we start using cross products. Cross products actually figure all that out for us, so they're nice and easy to use. But let's talk about this for a second. So what we have is just a cube, and on this top of the cube we have a force of 10 pounds acting straight in the z direction. At this corner of the cube we have a force of 15 pounds going straight in the y direction, and at this bottom corner of the cube we have another 20 pounds going straight in the y direction again. So let's just get into it. To find a moment, we multiply a force by a distance. So let's think about how each of these moments creates a force about, or a moment about what axis. Okay, so let's take this 15 pounds first. So the 15 pounds is actually going to create a force about our moment about one single axis, and that is the x-axis. So imagine holding this x-axis still. Imagine there's a pole there, and then you're going to pull this rope. Well, it's going to cause it to rotate around this pole. And so you actually have to do the right-hand rule for this case. What you do is you get your hand and you curl it in the direction that the problem is going to be rotating. And then whichever way your thumb is pointing is going to be either positive or negative. So for this case, hopefully I can get a little closer to the camera so you can see. The x-axis is coming here, right? And this force is going to cause it to rotate this way. So it's going to cause it to rotate around that axis in that direction. So we point it there. My thumb is pointing this way, which is negative in the x direction. So let's write that down there. And actually at the end we're going to sum all of these moments up about their specific axes. So sum of the moments about the x-axis equals 15 times something. And we know that it's going to be a negative moment. So negative 15 times, okay, so now we have to think about the perpendicular distance again. Well, this 4, yes, that is perpendicular to the 15 pounds because it's going in the x-axis, and our 15 pounds is going in the y-axis. But if you notice, the 4 doesn't really get us to anywhere specific. That doesn't get us to our point at all. So we know that we're not going to be using that 4. Now this 2, well, that gets us to our point, right? But that distance is parallel to our force, so we're definitely not going to be using that one. The distance that we're going to be using here is this 3, because that will get us down to the x-axis, the point we're looking at. I'm going to make one distinction here. Some of the moments about point A about the x-axis. Okay, so we have 15 times 3. Okay, and we already determined that this 15 pounds doesn't create a moment about any other force. So let's go on to the next one. Actually, we're going to do the 20 next. Now, does 20 create a moment about the x-axis? Well, if you were to pull this, And the answer is no, because the force passes straight through the axis. And if you remember before, whenever in 2D, whenever a force went straight through a point, it created no moments. It's the same here. If it passes straight through the axis, it doesn't create a moment about that axis. Okay, and it's also parallel to the y-axis, so it can't create a moment about the y-axis. The only moment, or the only axis that it can create a moment about is the z-axis. It's going to cause it to rotate like that. So we'll wrap our hand around, and it's pointing up, so it's going to be a positive moment. So we'll sum of the moments in the y, and then we'll come down to sum of the moments in the z. Actually, let's do that over here. So then sum of the moments in the z. Okay. So 20 times the perpendicular distance to get us to that axis is 4. So we have 20 times 4, and we already determined that that's positive. Okay. 20 pounds does not create a moment about any other axes. So let's move on to the 10 pounds. The 10 pounds is parallel with the x-axis. So we know that it doesn't create a moment about the x-axis. If you were to hold your y-axis and pull, it would rotate around the y-axis, go that direction. So it's going to be a positive about the y, 10 times this distance, this 3. Okay, but if we notice, it also is going to create rotation around the z-axis. So if we, that way it's going to rotate that way, but this is going to be negative. So minus 10 times, what's the distance? It's this 2. Okay. And then if we just do the multiplication for all those and add them up, that'll give us the moment about the x-axis, the moment about the y-axis, and the moment about the z-axis. So for problems like this, it's not too difficult. The hardest thing is just keeping track of which forces create moments about which axis, and if that moment is positive or negative.